So when we have double square root equations, these are a little bit more challenging. So let's see how we can solve these first by graphing. So let's graph this equation, and we can graph it like this, or we can graph the square roots against each other. Okay, so in fact, I think I'm going to graph x plus 1 against 5 minus square root x minus 4. So when we put these two equations into our graphs, square root x plus 1 and 5 minus square root x minus 4. Okay, so our graphs are going to look like this. So I'll just sketch in my axes. Okay, so we end up with a graph that starts at 1, kind of goes like that. Maybe I'll color code these. And this graph, the green graph, is going to be, it's essentially starting at 4, at x equals 4 and y equals 5, and it's going to end up being an upside down half parabola, and it looks like there's one solution right there. Okay, so when we find the intersection of that solution, okay, the intersection works out to be x equals 8. Okay. X equals 8, y equals, it looks like 3. Okay, so at x equals 8, we get y equals 3, and that matches on both sides, so our solution is going to be at x equals 8. Okay, and again, remember the graphs do not show extraneous solution. So this is fairly straightforward by graph. We could do this a number of different ways. You could have graphed the double square root on one side of the equation and then graphed y equals 5 and intersected that, or you could have made it all equal to 0, and again we would end up with just one solution of x equals 8. So a few different ways we can do this, and I just solved this, and then maybe I should put this in, but I just put this in a 10 by 10 window. Okay, but we want to also solve these algebraically, so we're going to deal with the easiest version first. So solving this algebraically, notice that this one's slightly different than the other equation, that we don't have that extra 5, and what that ends up doing is, and it makes it a little bit easier, because when we try to solve this, we want to get one of the square roots on one side. I'm going to add square root 3x minus 8 on both sides. And when we have square root equals square root like this, we can undo the square root, both square roots at the same time, and we're not left with any leftover square root terms. Okay, now if there is a plus involved in there outside the square root, that's a problem. Okay, because we cannot square. Remember, squares and square roots aren't compatible with pluses and minuses. In this case, it's not. In this example, this is not the case. I can actually get rid of the square roots in this way. Okay, and so there's my solution. I really should maybe set my domain again. So my domain, and in this case, there is no outside restriction because I cannot equal the square root to another expression. So we're only going to end up with 2 inside restrictions. We're going to end up with x has to be equal to 10 or less than 10, otherwise we get negative. So x is less than or equal to 10, and here x has to be bigger than 8 over 3. X has got to be greater than 8 over 3. Okay, so when we put this together, x has to be in between 8/3 and smaller than 10. Okay, so then when we solve this algebraically, I'm going to add x to both sides, add 8 to both sides. Okay, get rid of my 0 pairs here. I end up with 4x equals 18. Divide both sides by 4. So that simplifies to 9 over 2 or 4.5. And 4.5 is between these two numbers. That's going to be 2.6 repeating. Okay, and that's 10, so it's 4.5 is in between, so based on our domain, it is a solution that works. Okay, and again, if we want to test it, we can go ahead and test it now. It starts getting a little bit more complicated to test, so it is nice to be able to rely on the domain restrictions. But if I test it, this is going to be 10 minus 4.5, or square root 5.5, minus, okay, 4.5 times 3 is going to be 13.5, minus 8 is going to be 5.5, and that's equal to 0. Yeah, we're testing x equals 9 over 2, so that's a perfectly good solution. Okay, so that solution works with the test as well. So this is the easy version of this because we can make it into square root equals square root.